Hello, everyone.
Hello.
Hi.
We'll give 2-3 minutes for others to join us, okay?
Okay.
Thank you.
Morning.
Yes. I believe we may start now. I'll start by a reminder about our previous few lectures. The last important thing that we spoke about in topic 1, the full adder. This is the full adder, a program that we tested, and we put it in a subfolder. Then this full adder, it is just 1 bit. I'm adding X 1 bit, Y 1 bit, and I have, of course, carry in, and my output, sum, and cout. Then we spoke about if we want to make 8-bit full adder. So in this case, we started using this full adder that we had as a component. And we spoke about component that is a small module that I can call within the main program that is adder 8. So I moved this small component into my big folder that's called adder 8, and my project is adder 8. And to do that, I started using it by first adder 8. It has its own input and AB and Cin. Please note that AB are 8-bit each one. And Cin, it is one input, 1 bit. And here is S. The sum of AB must be another 8-bit.
Professor, are you supposed to be sharing your screen?
Oh, yep. Sorry. Thank you. This is my full adder, the program that we did. Now it is a component in a bigger picture. The bigger picture is this one that I have in here, adder 8. It is using 8 of this full adder, 8 instances of this full adder. Here, as I said, adder 8, it has A 8-bit, B 8-bit, C in 1 bit. The output sum, it is 8-bit, and C out, it is 1 bit. How to implement this component within my adder 8? When I start my architecture, the first thing to do is port. I am opening a channel between my adder 8 and my full adder. This port, I copy the entity, the elements within the entity of full adder. Those elements, copy and paste. Then I'm specifying my signal. My signal are those red lines. Those are internal signals. I am taking C out from the lowest significant bit into C in of the higher significant bit. Then I go to what is called instantiating, calling the component. Calling the component, I am calling the component for the first time, giving it A0, B0, and Cin. What will I get as an output is S0 and this internal signal. That is what I'm doing. The full adder, those are the elements, are mapped into this output. I'm repeating that for all elements. And I believe we all did that. Is there anyone with a problem with this one? Any problems? Okay. And I gave you a briefing about how shift registers would work, and I gave you also an introduction about counters. We saw shift registers. It can be serial in, serial out, serial in, parallel out, parallel in, parallel out. All of those structures, we saw them. And we saw also the counters. And we saw the up counter, the down counter. And at the very end, I asked you to watch a video, a small video that I made about test benches. And I asked you to implement this test bench and do this simple program. Is there anyone who has any problems with the test bench that I gave? The test bench, the video that I sent. Hello, Daniel?
Hey, how's it going?
Just fine. Have you made this test bench program, the small one?
Yeah, end test. I think
Okay.
it was under file end test. I did
Okay.
make, yeah,
Okay. Thank you, sir.
yeah.
Because the second topic, it is almost all test bench. VHDL test benches and course simulator. This is the structure. And as we saw in Adder 8, I called the component that was full adder, and the signal was the red lines. And here is my program that was mainly instantiating or calling the module that is called, or the component that's called full adder. So this is my VHDL language, and it may use library, and this is the synthesizable constructions. For test bench is some environment for testing my architecture. The test bench, it is like the wave generator that we use. It is going to give you a waveform of mapping between the input and output. So it cannot be downloaded to your hardware, but it is just for testing. But it is more sophisticated than the waveform, because this one, I can put some logic in it, in the input, for example. I can put some conditions for the input to go high or low, testing. All of those are extra features that are available in test benches. As I said, I have handout, I gave it to you, it is uploaded, and this is my video that you saw and you implemented. This is an example, just an AND gate. For this AND gate, I have 2 input and 1 output. It is similar to the NOT gate. And as you know, you can ask Quartz to generate a template for the test bench, and all what you need to do is to add this instruction for the input. How do you want your input to look like? My 2 inputs are A, B. So for this one, I am asking first A and B will be 0. Wait 10 seconds, then will be 0, 1. 10 nanosecond, 1, 1, and so on. This is a D flip-flop. D flip-flop. And here it has a clock. This is my program, D flip-flop. And the process here, if we have a clock, rising edge, Q will take the value of D. Now, if I want to implement a test bench for this one, we'll see here the test bench environment. This is my flip-flop. It is part now. It is going to be a component for the test bench. D in and clock, those are my input. My test bench program, the test bench as we saw and will see always, the entity test bench is empty. Why it is empty? Because it doesn't communicate with the outside world. It is just signal. It is a platform for testing. So it doesn't communicate with the outside world. And here is the architecture. The component I am calling the D flip-flop. This is my port. And this will be, all of those will be generated by my Quartz if I ask it to generate it automatically. And all of those are considered signals. Here in this one, I am giving initial values. If I want to add clear, this is extra. This is extra. So I have clock, D in, clear. This is my D flip-flop, and I believe in homework 1, you made this file. You have this file from homework 1. This is my component, this test bench. It imported the component and it generated the signal. And here is my port map, what the relation between the component that is this one and my test bench. Here, this is the port map. And here is, I have a process. This process, it is one process to generate the clock. Clock, not clock. Wait 5 nanoseconds. So I'm generating a clock that is oscillating every 5 nanoseconds. I have another process for the D flip-flop with the clear. This other process here, clear, will take the value 0 and D in will be 1. Wait for 43 nanoseconds. Weird number, but we are going to see on the waveform this 43. 43, I believe it doesn't conflict or doesn't match any of the changing of my clock cycle. My clock cycle changes every 5 nanoseconds. So this will not interfere or coincide on any transition period. Clear, 1. Now clear is high. So I want to clear my waveform. Wait 50 nanoseconds, clear is 0. What do we have in here? If I have a clock event and clock is 0, there is a clock event. Clock event means there is rising edge or falling edge. But here I'm specifying and the clock 0. That specifies that we are speaking about a falling edge. In this case, let D in be 0. I wait again until there is event. Falling edge, make D in equal 1, and so on. Now let's see how is that translated into a waveform? First, clear is 0, D in is 1. That is for 43 seconds. This is D in, and this is my clear. Clear is 0, clear is 0 for 43 seconds. This is 43. Clear is 0. After that, clear will go high. But for now, I have D in is high, and I have here my clear. When clear is 0, my output should follow my clock. My output is following the clock, is changing with the clock, but the input is high. So this will remain high. My output is high all the time because the input D is high and I have a clock. At 43 seconds, my clear went high. So my output immediately went to 0. For how long it will be 0? It says wait for 50 nanoseconds. So 50 plus 43, it is 93. After that, I have my D flip-flop ready to respond to the input in accordance with the clock. It was 0. Now I have a clock. I'll go high. Now it is 0. The input is 0. I go low. Output is low, and so on. I am going to leave you now to do this D flip-flop with asynchronous clear using test bench. As I said, this D flip-flop, you have it already. All what you need to do is to follow the instructions on the video and generate a test bench. After generating the test bench, you need to modify it. You need to give it the zeros and ones. That is, those are listed in here. Okay? Any questions? Any questions?
Not yet.
Yes, sir.
Oh, no questions yet.
Okay. So I'll let you work on it, and anyone may share the screen, and I am available if you need any help. Do you prefer working as a partners? Hello?
No.
Okay.
I had a question about this.
Yes,
So are we creating the circuit and then turn it into a test bench like the one that you showed us?
you have the D flip-flop, correct?
Yes.
This is the one you are gonna convert the D flip-flop with a clear. You had it from homework one. This
Okay,
is
we're just converting it.
to a test. You don't have to write it again. Just write the test bench for it.
Okay, I have a question.
Yes, sir.
So we need to put after process begin. This is a VHT file, so it's the test bench file.
Yeah.
So is this where we're putting the clear is 0, the DN is 1, and we wait for 43 nanoseconds?
Now we need to compare this to the file that I gave you.
On the PowerPoint?
Yes, sir.
Okay, so that,
You are gonna see that there are many things in here that are copy and paste from the PowerPoint, but still there are few things that are missing.
okay,
Okay,
yep,
including the timing. This is the most important thing, and they will not put it here for you. The test bench template, it is making you the structure. All
I
what
see.
you need to do to copy the timing commands, the input timing commands from the PowerPoint into here.
Okay, and just to be clear on the PowerPoint,
Yeah.
it's slides 9, 10, and 11.
Yep.
Okay, perfect. Thank you.
Thank you,
I'm a
sir.
bit confused. It looks like is this a new VHD file that we're making and then using the component with the clear, the flip-flop clear? Is that what we're doing? And then creating a test bench from this new project file?
My reference is my PowerPoint,
Okay,
and this template is to help you save you some typing time.
okay,
It is not gonna make your life zero typing. No.
right. Well, I'm just wondering because it says
Compare
flip-flop.
and see how you can make this template fit my PowerPoint. Clear, Cody? Hello, Cody?
Sorry, I have to tab through a few tabs. I think so.
Okay, go ahead, please, and continue working.
Hello, has anybody tried compile yet?
Yes, your question, please.
My question is, I'm trying to compile and I'm having error on the wait statements. So when we're asking to wait for so many nanoseconds, it's saying the wait statement must contain a conditional clause with until. The for, instead, where it has for, like 43 nanoseconds, my, Cordis is not showing, it's saying the nanoseconds is not, a proper statement for it.
I would recommend that first you need to test your program by waveform generator. And
But I have to
then,
compile it first before I can do that, right?
yeah, you can have test bench and waveform generator. Those are independent from each other. Is your program
Oh.
working properly with waveform generator? Then you translate that into the test bench.
Oh, okay, let me try that then.
Okay.
I think the problem is that it's not compiling. I'm having the same issue.
Not compiling. Have you followed the same steps that I showed in my video?
Well, I didn't start with a block diagram, so not quite, but I
Okay.
think I did.
Not starting by the block diagram, this is not the issue.
Right.
But there
Yeah.
are other steps that you need to take care of.
I added the file to the current project. I guess I'll look at the video again.
Just please look at the video.
Is the link to the video in the slides?
No, it's,
The
it's
video
on
is the
the
starting
announcements.
point. You cannot go anywhere without the video. You have to see the video and you have to do the example in the video before doing anything. That is the first thing I asked today. Have you all seen the video? Have you all done this simple NOT circuit? If not, you cannot go anywhere. This is the starting point.
So I have the wave, or I have the simulation, but when I go to view zoom full, it doesn't show me what is expected.
There is no output. The output is 0. Is your test bench includes the PowerPoint, the code in the PowerPoint, exactly?
Yeah, so I'm noticing that the value shows you instead of I guess yours on the video shows you also.
How did you get yours to compile? Did you not have that problem with the weight?
No. Can you guys see the wave right now? Or are you seeing
Oh,
or are you looking at the
the model
models?
sim. Yeah.
Okay. Yeah, let me go back. I guess let me show my code. One moment. Oh, darn it. Did I literally just exit out of it? Crap.
And the recompile phase went well.
It did, but I just exited out of, let's see, the VHT. Let me see if I can pull it back up. Let's see. this is what was on slides 9, 10, and 11.
I mean, you compiled this, Control L, and then when you started the test bench, you recompiled it as instructed in the video?
Yeah, I tried to follow it step by step. Let me try recompiling it again and just try doing the test bench one more time.
Okay.
So it compiled and I got 0 errors.
Yeah,
So now I'm gonna just continue with the
and you are linked, you are, go to assignment. Settings, yes.
the VHT file.
I cannot see the settings.
Oh, I gotta reshare it then. Let's see. Can you see it now?
Yeah, okay.
Let's see.
Now you go to what?
Assignments, process, no. Run simulation.
Did you hit simulation?
Yeah, are you not?
You
Is
are
it-
not following the instruction.
Well, I've got here, let me play. Let me go back and just follow the video then.
Please follow the video.
Okay.
There is 2 steps before this, or 1 step at least before this.
Okay, I've done this a couple times and it's still like I'm missing something.
Where is your recombile? Start.
Yep, start compile.
No, not here. Show me the steps. We are done with this part.
Yeah, so I got the VHT.
Yes. Now you go to tools.
Well, it's compiling right now.
Okay, we are done with this compilation.
Yeah.
Hit don't show again.
Okay. Okay.
Now what is next?
So now I'm gonna go to tools. No, I want to do assignments and go to settings.
You did that, I believe.
Yeah, it looks like it's already in here.
Okay, that's done.
Okay.
Okay.
So now we do tools, run simulation.
Yes. Don't show again.
Got it. So now and you can see the simulation screen.
Yes, I can.
Okay. From here, the video says to go to work,
Yes.
and then it says to right click and put recompile,
Yes.
and I get a failed.
Yes. Will you go up?
Go up.
Go up here. Maybe there is another message.
Oh boy. Okay, line 60 near component. I see. I didn't see that before. Line 60. And looking at the component. Oh, end component flip flop clear. Huh. Interesting.
It can be well before this line.
Okay. All entity clear is port. And so I'm looking at the PowerPoint and looking at this at the same time. Synth of D flip flop clear is begin.
This is the test bench, correct?
Yeah, the VHT file.
Would you please stop sharing?
Yeah.
The tent here I have entity test bench and there is nothing. Do you have this?
Can you share your screen?
Oh, sorry. This slide 10.
Slide
This is entity, test bench, end. There is nothing. Do you have this?
Huh, and this is lecture week 2? I think
Week
The
2,
power-
yes, lecture A.
that's so weird. The one that I'm looking at is different.
Are you sure?
Yeah,
Daniel, scroll up to slide 7.
okay, huh, interesting. Thank you. Okay, I'm gonna fix it.
This is the slide 7. I downloaded it. This is from Canvas. Have you got it?
Yeah, I'm working on it now.
Okay, I'll stop sharing.
So that's the test bench we're supposed to use, we'll slide 10 and then we just put in the flip-flop clear. No,
There is echo. I cannot understand a word of what you're saying.
Can you hear me now?
No,
I don't know.
you may type if you cannot fix the mic.
So is there a library component that we're missing here? Because I'm still getting the same error with the time, the wait 43 nanoseconds part.
There is no missing library.
Okay, so
Have you had
Mhm.
video running? If you have the video running, it didn't require any library. It is the same as the video.
Okay, so whenever I type in wait until 43 nanoseconds, the text for nanoseconds doesn't have the same like purple color, like it's not registering it as a time component, or something is missing there. I can share my screen if you'd like.
When I said type in my video, did I have a change in color?
I don't remember.
Okay.
Yes,
On your
yeah,
video,
yes, you did.
It's a
You're,
different color, yeah.
Yep.
But there's no space.
yeah, there's no space, so I could try that. Oh, that might actually be it. Because that did change the color for me.
You have your program, the node circuit in test bench.
What was that? I think I actually got it to work.
Oh, good news, good news. Share the screen, please.
I'm still working through it, but I've got 0 errors, so I'm following along behind you, Taylor.
Okay, will you please enlarge this?
Yeah, I'm trying to.
I'm thinking about maximize this window. Yep, just a moment, let me check. I have the clock working. What is the second one? Because I cannot read it. This is the clear.
It's clear, yeah.
Yeah.
And then D and then Q.
The third one, what is it?
D,
This is the D input.
yeah.
And the last one?
Q.
Oh, you have selected some, but it is correct. But because you are making a huge clear, can you see it? So it is ignoring the D in, the change in the D in, you cannot see it. This is
Okay.
hard, but it is working perfect.
Oh, good.
It's working according to what you have written. You have written here. Okay,
Okay.
this is working perfect. Thank you very much. Anybody else?
I should be there in a couple of minutes.
Okay. The test bench on slide 7 is the one we use, and just add. Yes, 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 Bart. Taylor,
Yep.
would you show us one, the D flip-flop you have, then the test bench you have?
Okay. Let me try to change my resolution really quick so it's easier to
Okay.
see. Okay, so this is the D flip-flop clear.
Yes, the same as we had.
And
Thank
then
you.
the VHT file.
Now, would you please move slowly and let us know what are the parts you changed in the template?
Well, I kind of wrote all this out.
You wrote it all down.
Yeah, just
No
from
problem.
from the slides, and then I just copied the whole thing into the file, so it was replaced completely.
Okay. You have everything here in a subfolder, correct?
Yeah, it should be in the simulation model sim. This one right here.
You have what are all of those?
It's probably for me trying different things to figure out how to make it work.
Okay. Would you please keep whatever we have seen right now and delete the rest? Then
Okay.
what I'm going to ask you to do is to make a zip file, mail it to me, and I'll mail this as a reference for everybody.
Okay.
So everyone we have this as a reference for you. You still need to make your own because we have others.
So just the VHT file?
No, VHD, the D flip-flop and the VHD.
Okay,
Complete system that runs.
I'll just give you the whole folder then. Yeah.
Okay,
Okay,
just mail it to me and I'll send it to everyone. Now I'll share the screen. I'll be mailing you this and you have it as a reference while you are making your own. Now I'm gonna show you another program that you did also in homework 1. That is D flip-flop with asynchronous clear. This clear is tied to the clock. This is the one you made already. And here in my process, I put clock and clear. This is from homework 1. And I believe here we are going to have almost the same test bench. The same input, the same output, almost everything here. And you can see I am using the same, everything is almost the same. Even the clock, not clock, is 5 nanosecond. Here, the only difference, it is at 43 nanoseconds, I have here the command, but I didn't change anything until I have my clock. The flip-flop will be clear. This is the asynchronous. This asynchronous, yes. Asynchronous means it doesn't follow the clock. This is the second one, the synchronous reset. Again, the same one. So the same test bench. Here you can see the difference is at the clock, I am changing. At the clock, I am changing. The reset itself, it follows the clock. So we have 3 programs that would use almost identical test bench. Sometimes I call it clear, sometimes I call it reset. Normally we use the word reset when we have it synchronous. It is tied to the clock. This is with enable. Again, this D flip-flop with enable. When the enable is high, the output is activated. This we had it in homework 1. As you can see, if enable is high, I follow. Again, I have the same structure. And I have here now enable. I don't have clear or reset. Enable is to give me the output. And as I told you, the same test bench, 5 nanoseconds. As you can see here, the process of enable, wait until falling edge clock. Enable will be 1. Then wait until falling edge. Now it is 0. That's how this enable is working. It has a process, as the clock has a process. This is the simulation waveform again. Now we go to binary counter. This is part of our new homework. My new homework, we're gonna go over it, but this is the first or the third part, binary counter.
I noticed
Yes,
the homework says it's due tonight. Is that
would you
All right.
please check the due date again?
It's been changed. If you look at it now, it's like
Okay, thank you,
February 10th
thank
or
you.
something.
No problem, I changed it.
right?
Okay. Counter, how it works. I have here counter, clock, enable the counter, reset count. And I have a signal. The counter is 3-bit counter. So it can start counting 0, 0, 0 up to 1, 1, 1. My process upon the clock, if rising edge, if I have a reset, the counter will be CNTR. This is my signal. This is my signal, CNTR. I will have it 0. Else if enable, I have enabled, the counter will increment. CNTR will be CNTR plus 1. And the next step, whatever this CNTR is, I put it in onto my count. This is the same as we did before. Counter. This is the test bench for the counter. And this is the waveform. Let me go and see the homework. This is homework 2. Can you see here? I need 8-bit counter. The counter we have here is 3-bit only. So I want to make a counter 8-bit. So we need to update this to account for 8-bit. What else? It says with clock and reset. The reset signal should be synchronously reset. Synchronously means it is dependent on the clock. So in this example, I don't need enable. I need only reset. If you wanna keep the enable, no problem, keep it. And here, I have here my reset. It depends on the clock. So everything is the same. Everything is the same here. All what we need to do is just make it, instead of 3-bit, I need it 8-bit. Any question about problem 3? Any question about problem 3? Here, I have number 4. Number 4 is 16-bit. So my 8-bit will be 16. It has a clock and reset. That is the same. We had clock and reset in the previous 2 examples. In addition, I will have up, down. There is a new input that is called up, down, UD. In this counter, I am saying counter incremented by 1, adding 1. So I will have here another condition. This will be happen if up down is high. I will increment. If up down is 0, I will say CNTR will be assigned to the value of CNTR minus 1. So I am decrementing. So incrementing or decrementing. I believe this one is also in homework 1. For homework 2, now you are free to use test bench or use the waveform generator, whatever you like. Okay. Now let me go to our homework 2 again. What do we have here? We have number 1, 4-bit shift register. 4-bit shift register. We spoke about shift register last week, and we saw how the data will be manipulated. So if you need a reminder, you can go to the same lecture and see it. And to implement this one, you can program it to move it, but there is a command. There is a function in our VHDL. You can use it to make this shift register. It will make your life much easier to use this command. I'm not gonna give it to you, but I want you to search for it. Maybe you can watch a YouTube, you can search the net, you can search the library, you can find this shift register. Data in that will be shifted, and of course it will be shifted according to clock. And I have a reset command that can reset it to 0. Then we are going to move to another shift register This is 16-bit. This 16-bit, it loads according to command. All 16-bit will be loaded simultaneously. That means it is parallel in. So I can parallel in the 16-bit. The first one is serial in, serial out. But this one, it is parallel in, serial out. When the load signal is there, all data in will be available and coming out. Then when you hit shift, it will be start shifting. Again, I need you for those two to search the command, the VHDL function that is for shift register. Again, for those four, I need from you to use either waveform generator or test bench. From now on, you are free to use either one. Now I'll see my mail. Oh, I got a mail from Taylor, the D flip-flop. Would you please all check your announcement? Please run the file that you received. Make sure it is running. Hello, Daniel.
Hello?
Did it work well with you? The file I sent you?
I'm looking at it now and I'm not seeing a test bench, like a VHT file in there.
Oh, because you didn't or you don't remember my video. The VHT file, it is not in here. The VHT file, you can go to the model sim subfolder and then you can find it.
Yeah, that's what I did. I went there and it's not there.
Uh,
Let me show you.
Is it in the root directory?
That's how it is.
It can be in the root directory.
So this is the download. Sim, model sim.
Wait, did you extract
can
the
see
zip
it, I
file,
can
or
see
did you
it.
just try opening the zip file?
Yeah, I extracted it.
Yeah, yes, I can see it. I can see it without extracting.
Huh. Does anybody else see it in theirs?
Just a
Yeah,
moment,
I can see
please.
the mine.
Let me share the screen.
Okay.
This is the file that we got from Taylor. The flip-flop. And he followed the instruction. And this is simulation, model sim. And you can see here, .vht. Didn't you do that?
Do you have it set to show all files?
Ah,
Please let me know when you do that.
So I'm gonna pull mine up. I'm having some troubles.
Not working? What do you have?
I'm not sure. Like it looks like it's working, but
No, this one is not working. This is the one you got?
yeah. So can I just share my whole screen? Anyway,
While you have everything, you still need to go and compile at your machine the code. Then you compile the VHT file, and you need to let the setting of the processing know where is this VHT file. Then you go to tools, RTL, and recompile again you follow the same steps. But in this case, you have the file already.
Okay, I'll give that a shot first then.
Please do.
I followed along and it's showing that there's an error for me. Paused at line 12.
That is while you are recompiling.
Okay.
Took some tinkering. I think I got it.
Oh, you got it running?
I think I got the one
Excellent.
sent to us running. It's not my own. I figured out what was wrong with my own.
Okay, what was wrong? This is very important. What was wrong?
So for the one I've been writing, the test bench, I generated a VHT, like the video showed,
Yeah,
but I didn't realize that we could redo the VHT with what was in the PowerPoints. I thought we had to try and adjust what was created for us.
yeah.
And I was having a really hard time with the clock cycle, but I think if I go through, delete what it pre-builds in the VHT and just write it out like the PowerPoint, I think it'll be fine.
Okay, great. Thank you.
No problem.
At the moment, what I urge you to do right now is just go ahead, and we saw many examples today for this D flip-flop, and they are almost using the same VHT, maybe changing clear to reset or enable, things like that. So please try one of those. Try one of those on your own. Now you have one that is running, that tailor-made, and I passed it to you. So you can make one of your own, and then you start working on the homework. Okay?
Sounds good to me.
We have 15 minutes, and I'm going to be around waiting for any questions from you. Again, if you want to leave, you are welcome to leave. No hard feelings. I'm not going to be disappointed. You can leave if you have no questions, or you can manage, or you can stay with me the coming 15 minutes. And of course, we're going to start a new topic on Tuesday night. Thank you.